Okay, so this is the last section of our video, and in the previous video, we started by building our parameters, building our geometry, inserting our materials. That was in the first video. And the second video, what we did was we added our physics, defined all those parameters and variables in the physics sections. And in our final video, we're going to mesh and computer work. So I've also inserted the links to all those videos in this under the video description. So if you haven't watched, please kindly watch it before you watch this video to get a better understanding. Okay, so let's move on. So we'll be meshing our work. We go to mesh and we are using a free triangle in this work. So we select a free triangle in here. Let's choose a domain and okay, select. Okay, so yeah. Okay, so 1, 2, 3, 4, 5, 6. So this domains are for the free triangle. And what we'll do is we right click this triangle to add a distribution. Distribution. Let me paste 35 and paste 6. Okay. So in the settings window for the distribution, number of elements, let's increase it to 10. Let's increase it to 15 or 20. I don't know. Let's uh, let's add mapped and under the mapped, under the control entities, what we can do here is let's uncheck this side. And under the mapped, let's add okay, let's add a distribution. Under the distribution type, we should use predefined. Yeah, let's use predefined. Yeah, I think we should use predefined now. So in the number of elements text field, I just want us to keep this to let's make it like 30. In the element ratio, let's make it 10. Let's reverse the direction. And also the boundary selection, 24, 26. Let's add 24. Add 22. Now let's add 20, 29, and 28. So we have 20, 22, 24. Let's take 25 out. 26, 28. Okay. Yeah. 1, 2, 3, 4, 5, 6. Okay. Okay, we made it predefined here. And let's go on to build all. So as you can see, okay. So as it moves towards the side, the mesh increases, increases, increases. Okay, so now that we've been able to mesh our work, and please, your finalized mesh should look like this. Please make sure that what you're getting is the same as what I just did. If you're not getting the same, then you have to delete what you did and you start all over from the mesh as I started to get this. So I think we can move on from here. So I want us to add a probe here. So definitions, let's add a probe and let's add a domain probe. And for the domain probe, okay, let me see. Let's label this as the maximum temperature probe. Let's choose maximum. And this will be T. Okay. We'll go on to add, let me see. Okay, we go to non-couplings and we want to add a maximum. Source selection has to be all domains. So now our mesh physics, everything is complete now, and we can move to study our work. So we study it in two sections. One, we do the battery cell pattern, and we turn off that for the heat transfer. So let's start with the battery parts. Let's go to study one. Under the current distribution, initialization. Okay, let me increase the size better because you're now looking at the section. Let's uncheck this. You don't want to, you want to turn off the heat transfer part when you are solving for it. So you want to uncheck. So when it's going to solve, it's not going to solve for that part, just for the battery section. So that's why we are turning off the heat transfer. So we just want to first initialize the battery cell. Okay. Okay, so after doing this, now we go to the time dependent and we locate the steady section. Okay, so the times range we're going to change. We're just going to do 10 to the power range. So we have 0.5 to about, let's say, -1. Okay, let's steady to, let me add a parametric sweep. Okay, we're going to add a parametric sweep to steady the inner radius of the penetrating film filament. One, 5. Okay, so we can now compute. Okay, so wait for it to compute. We wait while waiting for it to compute. So it takes a little while. And I'll show you some plots that we generate from this work, then we are done. Okay. So as you can see, let's go to results. We go to evolution 2D. Okay. When we go to revolution 2D, in here, we have our solutions. Okay. Okay. So it's just by under the revolution 2D and the start angle, you can make it even minus 180 to the angle, we can make it 270. Let's plot and see. Okay, so this is what we get for the revolution 3D. However, if we should then change this to 90 and 360 or 90 and 270, depending on what I want to see. And let's go to the plot groups. Uh, 3D plot group. You can make it like this, temperature revolution. Let's see, temperature revolution. And you add a surface to it. And under the expression, we're going to make it temperature. So you see the temperature, plot of it. So looking at the times, maybe you can make it like, let's see, how it begins and how it generates. Let's add another plot group. And also generate another plot by results. We add a 1D plot group. There's the temperature. How we get this temperature along this temperature along this separator. Let's make it so temperature along the separator. Now the data section. We use 31 parametric solutions. Let's choose last. And let's add a line graph. And under the y expression, y-axis, let's type T, temperature. The x-axis data, we're going to use an expression. You have to select the boundaries. We have to select boundaries. 16, 18, and 26. These are the boundaries that when we have our plots of the temperature along our coordinates. So we can also plot how we plot the total state of charge. I'm going to show you how we plot it. We go to 2D plot group. That's the state of charge. And we add the surface. We're going to change the expression over here. It's under lithium-ion batteries. It's under particle calculation. So it's this one, local electrode material, state of charge, that's the particle surface. And we plot. So we have it here. So this gives us the plots of the state of charge. And what we can also plot is the maximum temperature versus time. And the results, we add a 1D plot group. That's the maximum temperature versus time. Under the data set, we choose parametric solutions. Under the legend, let's position the legend to lower right. Let's add I think we can add a global, locate the y-axis, and put this expression in here. Mm-hmm. On the degree Celsius. Yeah. Description, we want it as maximum battery temperature. And I want us to put the legends. Let's uncheck the description. Okay, let's plot. Okay, so we have the maximum battery temperature versus time. So these are some of the plots that we can generate from our work, and I hope you're able to follow our work to this point. If there are any questions, kindly let me know. So hopefully I'll see you in the next video, and thanks for watching.